Hello friends, students and everyone here. Today we are going to start the important terms in thermodynamics chapter class 11th as per the NEET syllabus also, and IIT is also included here. And first of all we will take state function and path function. What it means, state function, path function. It state function like pressure and temperature or volume, which depends on the state only. It depends on the state. It doesn't matter how that state is reached. That are known as state function. Okay, next is path function. This is depend upon the path carried. Okay, which path we have followed, that is the important part. The example of path functions are work and heat energy. Clear? These are the two variables that are known as state variables: pressure, temperature and composition. These are the variables. So I think this is clear to you, state function, path function. Next part we will take the internal energy. Internal energy, what do you mean by internal energy? The total energy. It is the total energy contained by a thermodynamic system. Thermodynamic system. The energy of atoms, molecules, the interaction, all the energies which came under the internal energy, which is denoted by U. Okay, this energy involves thermal energy, rotational energy, transition energy, all of this. Okay, so we can say that value of thermal internal energy cannot be absolute value. Absolute value can't be determined. Absolute value means perfect value can't be determined. For example, our we take the example of our intelligence. Can we define the absolute value of our intelligence? No. We can only say that if we have given an exam, we have pass or fail. So it can be basis of that only. That is also like internal energy. Absolute value, perfect value cannot be determined of internal energy. Okay. You can only say that change in internal energy can be defined. Change in U can be defined, which can be represented delta U final minus initial. You can see in this picture what is internal energy. Delta U, it is a change internally. U final minus U initial. Okay, now U can change. Delta U may change when there are conditions in which U can change, whether matter enters or leave the system. We have discussed system surrounding in the previous video. Second one, heat, which is represented by Q. Okay, either heat passes or it gets out of the system. These are the basic terms. Okay, it passes in the system, then we have to take plus positive sign, and if it leaves the system we can take minus q. Okay, next is work, which is it is denoted by w. Okay, work done on the system, work done on the system or by the system, by the system. If we work done is on the system will be positive, and work done by the system will be negative. Clear? This is the factors by which you can change. Okay, now internal energy, the first law of thermodynamics is there. The total energy of system is constant. Remember that. This is the first law of thermodynamics. This is the first law of thermodynamics, which gives delta U is the change in internal energy. Q is heat, either coming or going outside the system, or W is work done on the system or work done by the system. Clear? Next, we can say that energy released, when energy is released, delta U will be taken negative in the case of release of energy, and when it is absorbed, it is taken as positive. Remember that. And the total isothermal energy, isothermal process in which heat is constant, delta U become 0. Okay, because there is no change in temperature, so it will be 0. The energy of isolated system will be constant. The energy of the isolated system will be constant. You can see here delta U is equal to Q plus W. So this delta U is a state function, and Q and W are the path function. Clear? The next part is enthalpy. This is the most important part according to the board exams and the competitive level exams. What is the enthalpy? It is the heat content of a system at constant pressure. Okay, you can also say that in the chemical reaction, amount of heat absorbed or amount of heat released is also known as enthalpy. It is represented by H, and the equation is U plus PV. Here U is internal energy, P is P external pressure, and V is the volume. This is the equation of enthalpy. You can say that the SI unit of enthalpy is joule or kg per mole, because how much work done in 1 mole or 2 mole, that is known as kg per mole. Okay, so internal energy can also be represented as E also in some of the books. If we take the example here, this is a system, there are the molecules are here. Okay, well, the energy consumed by the molecules, the interaction, it is known as the internal energy U. Okay, between the molecules and between the atoms, that is the internal energy. So H heat content. What is will be that heat content is equal to internal energy plus, now this you can see, to establish some system at any pressure and any volume, the work is done, the work should be done. So we can write here, to establish system at pressure, volume from empty space, because something is reached from somewhere. Okay, so this is the internal energy plus PV. P is the external force, P external. Okay, V is the volume. Clear? Internal energy is of molecules and of atoms and can be of electrons also. Okay, next part is, you can see in the diagram, enthalpy, heat released or heat absorbed. It is the enthalpy, that is important part. Okay, next is the intensive and extensive property. Intensive and extensive property. Extensive property means which depends on quantity or size of matter, how much matter is present, that is the extensive property. Example, you can say mass, volume, internal energy, height, capacity, enthalpy, entropy, Hamilton's energy, Gibbs energy. Next one is intensive property, means which does do not depend on size or quantity of matter. So this is all about in the video. Please like and subscribe my channel for the more chemistry updates. I will continue to make the videos regularly, so please follow me regularly. So we can say that this is the part we have done in most important part, which okay,